and we're talking about antiderivatives. Well, we used to play the derivative game, right? If I gave you a y, I asked you to find a y prime. But when we play the antiderivative game, I'm going to give you a y prime, and you've got to give me the y value. And there's this weird thing that we need when we take an antiderivative, that we get this constant of integration. So you can kind of see, right, if I have y equals square root of x, y equals square root of x plus 1, y equals square root of x minus 3, right? They all will have, at that point, they'll all have parallel tangents, right? So when I give you the derivative, you don't know what it is. Is it a mother function or a daughter function, right? Does that make sense at all? So when I'm starting with a derivative, I know that constant, whether it be 1 or 0 or -3, got killed by the derivative. So when I'm going backward, I want to make sure I think about, right, that it could have been there, right? There could be some kind of constant there that was killed by the derivative. Does that make sense at all? So we're going to have about a list of 12 ways to try and find antiderivatives. And then when you take Calc 2, it'll become a list of 24 ways to find your antiderivative until everything fails. And then we teach you how to turn every function into a polynomial. And then it's always easy to find a derivative or an antiderivative of any polynomial, right? That's the end of that's the end of Calc 2. That's that beast piece, the most difficult part of it. So, but we start writing our integration checklist. That's what I call it. So we'll go through maybe the first 2 of 12. Maybe Wednesday or Friday we'll try and do the third piece on the list. And then we're full into chapter 5 after that, which is cool. So Wednesday I'm going to teach 4.1. So our integration checklist is you know y prime, right? So you recognize y prime, and you instantly know where it came from, right? You know y prime and where it came from. So for example, y prime is 1 over 2 square roots of x. We know that one by heart, that y must be square root of x plus that constant c, right? You just recognize it, right? So example, y prime is sine of x, cos of x. The derivative is cos of x, right? So you know where y is, right? What is it? Yeah, sine of x plus c. And when you're doing these antiderivatives, you're moving the opposite direction around the circle, right? So if y prime is sine of x, what do you know about y? Negative cos, right? You see it moving that way around the circle? So c minus cos of x. Right, c being that constant of integration. If y equals e to the x, sorry, y prime is e to the x, what's y? E to the x plus c, yeah, plus that constant. There's one special case. Everybody okay here? This is easy, right? Those optimization problems are not easy, very long, but this is, at least we get a little break with this, right? So one special case of this is if y prime is 1 over x, y is the ln of the absolute value of x. So this is different. This is the only one that's kind of special, but we definitely recognize the derivative of ln is 1 over x, right? Derivative of ln of x is 1 over x. But why all of a sudden do we need this absolute value? So it's important that you see when I'm talking about the original function of 1 over x, the domain is what? Everything but 0, right? So in order to accommodate that with my original function, I need to get both pieces of this ln to happen here. This is y equals ln of absolute value of x. But when I played my derivative game, if you see the original function ln of x, that's just x is positive, right? The domain here is from 0 to infinity, open, right? So when I'm doing my derivative of that, all I care about is the positive 1 over x. Right? Do you see the difference? So if I'm starting something with a restricted domain, my derivative is on that restricted domain. Right? Same thing, if I'm starting on a derivative with a domain, I want my antiderivative to be on that domain. And I guess the tricky part of that is seeing that y equals the ln of absolute value of x can be done as a piecewise function. So if x is positive, just use ln of x, right? And if x is negative, use ln of negative x. Right, like if I want to plug in 2 there, right? If I want to plug in the ln of the absolute value of 2, well, that's just ln of 2. That's what they goes up into the positive, right? If I want to plug in negative 2, I use this one, and then I get ln of the opposite of 2, right? So, but let's do our derivatives there. So what happens to the first function? Well, it's the derivative of the inside over the inside, so 1 over x, right? And then the derivative of this one on the inside is a negative 1, but over negative x. And you see that it just becomes 1 over x again, right? Some books stress this absolute value piece, some don't. Yours doesn't really, but in Calc 2 we will, and in DiffyQs we will, for the engineers. Who are the engineers again? Yep. So when you see this in Calc 2, right, or DiffyQs, you'll have to be worried about these absolute value pieces. The second piece on our checklist. We ready? We okay here? The second piece on our checklist is a power rule. So So for example, if y prime is x to the n, y equals x to the m plus 1 over m plus 1 all plus c. If you remember what I did in my derivative game, when I took the derivative of x to the n, I multiplied by the power first, right? What am I doing here? I'm dividing by the power last, so I'm undoing the derivative. What else did I do to my power when I took the derivative? I multiplied by it, and then I reduced it by 1. So what I'm going to do when I'm undoing the power rule is I add 1 to the power, and then divide it. And then put constant integration. So if y prime is 2x, we already know y is x squared plus c, right? X squared plus 3 or x squared minus 5 or whatever, right? You with me? But let's look at it with the power rule, right? I'm going to add 1 to my power and divide by the new power and add a constant c. So I get 2x squared over 2 plus c, or x squared plus c. So power rule. So first thing, you recognize it. You know where the function was. It was our first look. Our second look is look for a power rule, right? So for example, y prime is 1 over 2 square roots of x. Well, that's x to the minus 1/2 over 2, right? Yes, you agree with that? So y, I've got the x to the minus 1/2 all over 2. Add 1 to the power, divide by the new power, and add a constant c. Add 1 to the power, divide by the new power, add the constant c. So what do I get there? X to the 1/2 over 2 over 1/2. So there it is, square root of x plus c. I think that's enough for today. Get some of that packet done, okay? Get some of that packet done.